Good morning, everyone. Thank you for joining us today and welcome to Production Modeling Corporation's web presentation. Today's topic is 9 steps to creating a successful discrete event simulation model. This will be co-presented by Edward Williams and Kaur Tosi. Edward Williams is a senior technical specialist and Kaur is a digital manufacturing engineer here at PMC. On a housekeeping note, we will be muting all phones and microphones throughout the presentation to eliminate any background noise there might be. So if you have any questions, we recommend you type those into the chat box and we'll address those at the end of the presentation. To start, I'd like to do a brief introduction into PMC. Since 1979, PMC has helped over 700 companies by completing more than 8,000 performance-enhancing initiatives worldwide. It is our commitment to excellence that has brought us to the point we are the largest independent industrial engineering services firm here in North America. PMC has worked with hundreds of businesses across all industries to improve their business's performance. And shown here at the bottom of the slide are just a few of our current and repeat customers. Today's session will be focused around discrete event simulation, but here's a sampling of the other services that PMC offers. This includes factory design, laser scanning and CAD modeling, lean, quality and operational excellence, and traditional IE services. If you are already underway with productivity improvement initiatives in your company or wondering where to start, PMC can help you. Now with that, I'd like to turn things over to our first presenter, Edward Williams, to begin our presentation on 9 steps to creating a successful discrete event model. Ed, take it away.
Thank you, Brian. Ed Williams here, old and gray and wrinkled. I've been doing simulation work for more than 40 years now, and that's nearly half my lifetime so far. And a successful simulation project is well worth the candle. Return on investment routinely greater than 10 to 1. Rare that it's less. Now that's a successful simulation project. And 100 to 1 is not at all unheard of. I've seen it multiple times. Not only the high return on investment, but a successful simulation project can really produce cost avoidances. The whole idea wouldn't work. Thank goodness we found out before we build a whole plant or remodeled the whole warehouse or whatever. We found early and inexpensively and without disruption right on the computer screen, and that was a good place to find out that the idea was not going to work and needed a complete reworking, redesign, back to the drawing board. So we battle-hardened analysts will explain, since a successful simulation project is such an enticing goal, what are the 9 prerequisites for having one? And specifically, I want to point out that these steps are completely independent of what simulation software you might eventually use. There's many out there. The very first thing is climb the mountain. Where are we going? What is our objective? And the objective is not, we're going to model whatever. Building a model is not a goal in itself. It's a way to achieve a goal. What is the goal and what is the scope of the model, as small as possible to achieve the goal before you do anything else. Now, it's a little bit better to say we're going to model the factory, the warehouse, to improve productivity. That's nice. it's almost certainly too big to start with. It would be better to say, we've discovered that Department X is our pain point. In fact, that's painfully obvious. So we're going to model Department X to look for ways to improve productivity. Another improvement, stepping forward towards a really strong objective and scope, we attach a measurable KPI, key performance indicator, like time spent in the department. If you do or don't reduce that time by 20%, you'll know it. Now, even better gets to this point. We have three possible improvements. Somebody has to propose them, like a subject matter expert. A simulation model by itself in the software is never going to propose an alternative. No software is going to pop up a little window saying you need a faster machine here. So a sensible, knowledgeable analyst may have come up, I really think we need a faster machine at this point. Well, no, I really think we need an additional worker to be assigned to certain tasks. Well, no, the problem really is that one of the machines has too much downtime and we need to reduce that downtime. Now you've got three competing ideas. And that is going to lead to 8 alternatives. Alternative number 0 is what you've got now. And you've already decided it is unsatisfactory. Therefore, you're going to look at a simulation project. Very importantly, one of the most valuable abilities of simulation analysis is that it can analyze possible synergistic effects among possible improvements. It may be that ideas 1, 2, and 3, each individually, won't do you much good at all, not worth the price they would cost. But it may be that ideas 1 and 3 together will produce a marvelous improvement. Simulation software will find that out. After building a model of what you've got now, it will be surprisingly quick to put in alternatives 1, 2, and 3. Adding each of those alternatives might be a task requiring about half an hour. So there's the good alternative. Numerically measurable objectives, a well-defined, ideally narrow scope, especially for your first model, and a list of alternatives to be considered. So do this, objectives and scope, before taking any other steps. Now, having decided to embark on this well-defined project, you need someone in charge of it. If everybody's in charge, then nobody's in charge. So you need a person, I've called it on this slide, project lead analyst. Call it what you like, title you like. And that person has authority specified by top management and well publicized as the project leader. And that person has both the authority and the responsibility to set the timelines and the budget. And ideally, this project lead analyst has seen at least one simulation project fail. Well, in 40 years, I sure qualify on that one. And indeed, for our clients, I've taken this role multiple times. A person who has seen a failure knows what not to do over again. Now, this project is going to need time and expertise from various people, like data gatherers, people with process knowledge, statisticians, various types of expertise. Their time and expertise is going to be needed in the requisite amounts at the right times relative to the project timeline. And the project lead analysis has the power to insist that that happen. And likewise, the project lead analyst can commandeer software for simulation, software for statistics, software for data archival and organization, expertise in modeling and in statistics to establish a road toward the project objective shining out there on the horizon, because you did that in step one. As Sherlock Holmes said, one of the famous Conan Doyle narratives, I cannot make bricks without clay. You need the right data at the right times. You may be modeling a hypothetical system that is still on paper only, in which case these data will have to be estimated by experts. And those estimates of any data that must be estimated need to be documented, archived, and achieve concurrence for all these assumptions made by all the project stakeholders. Now, on the top half of the slide, I've listed 7 types of data that always are needed. Well, at least in 40 years plus, I've never seen a project where one of them was not needed. And ultimately, you out there are going to be the experts on your process, and you can suggest additional things needed to fill in the 4 dots at the end of that list. The model will not run and produce reliable results from which conclusions will be drawn without accurate data. And having gathered or estimated these data, statistical analysis needs to be done. And that requires some expertise and some software. Specifically, a project is going to need distribution fitting software, such as we have here routinely at PMC. And you need an expert who knows the proper use of that software, when to use which of these tests. Look at all the name dropping I've thrown in here. You need the availability of one expert who knows which of these tests to use, when and why. The input data analyst needs to be aware of the dangers of autocorrelation, beginning by knowing what it is. And we have other webinars that go into detail on these finer points covering individual stages of a successful simulation project. And likewise, the analyst needs to be able to recommend what should the model runtime, warm-up time be, and how many replications of the model are needed. And by now, only now, you're ready to step up into the software, and my colleague Kawatoshi will now take it away with detailed advice where to go from here.
Thank you very much, Ed. Hello, everyone. And continuing the topic, how do we select the discrete event simulation software that we use in our projects? So to find that out, we have a few questions. What will be the purpose of the simulation study? Is this a study that will be carried out within a 2D environment or a 3D animation? What level of detail is required for this 3D animation? Will the company buy the simulation software or will it be leased? What features will be used in this project? We will work with operator modeling. We'll model robots. We'll model AGVs. Um, what programming language should we use in this project? C++ or Simtalk, Python, Pascal? We must choose the software that best meets the project's requirement, and we need to have an expert able to work with that application. So these are some of the questions that we should take into consideration before moving on with discrete event simulation software. Entering the part of the simulation specialist, the modeler must have a deep understanding of the simulation software he'll work with to build his model. The simulation specialist must know how to correctly model and fill in the parameters within the application. The specialist must perform the process animation that exactly reflects the process in which it's simulating or the proposed scenario. The simulation specialist must know how to input and how to correctly read the output data of the software. Well, once the model is built, we enter the verification and validation step. Does the model work as expected? Again, as the expert's role, he must perform all model verification and analysis to ensure that the simulation conforms to the actual process or to the process that is expected to be simulated. And here, in this step, we can include some breakpoints, or we can add displays. We can use watch and break features that can access the specialist in the validation step. It's also part of the expertise of the specialist to know how to perform the correct analysis of the outputs obtained with the simulation so that he can make assertive decisions based on the values found on the simulation. Um, it's also the expert's role to create experiments, to simulate multiple scenarios, use what if tests, and build confidence intervals. The correct interpretation of the output brings us better decision making. And finally, we enter the important step of documentation. It's at this stage that we'll document the objective of our simulation study, what were the assumptions used in this project, all the input data included in the model, under which layout the model was developed, the results collected from the simulation, the analysis of the output obtained, the conclusion of the simulation study, and also the recommendations. Um, in addition, depending on what was modeled, we can also include into this step some resource utilization graphs and buffer occupancy graphs. Here, each time the simulation model is updated with new input data for new projects, for example, it's advisable that a new documentation is generated so that the history of results is maintained for all the team. Well, here we cover the 9 important steps and actions to model a successful discrete event simulation. And I will give Brian the voice again so we can get into the Q&A section.
Yep, thank you, Cora. We did have a few questions come in throughout the presentation, and we'll get started with those. But please, if you have any questions for either one of our, presenters, please be sure to put those into the chat box, and we'll have them discuss those with you. So, gentlemen, the first question that we had come in was, when a simulation project fails, what is the most likely cause?
Well, two horses in that race. One is there was never a clear objective and scope defined. And the other horse I'd put in that race, as unfortunately a strong contender, is inadequate data, or what's even worse, wrong data. Wrong data is worse than no data at all.
Thank you, Ed. The next question that we had come in, how do we ensure that the results we are getting through the simulation are accurate?
Good question. At first, still in the data input phase, we must make sure that the parameters that we are including into the simulation are correct and that reflect with the current system or with the future system to be simulated. In this phase, the more detailed and rich the input data, the more realistic the model output will be. So input as work shifts, process time, downtime, availability, MTTR, speeds, and also capacities must be well positioned into our simulation study. And also in the validation stage, the modeler, the specialist responsible for the modeling, must perform a deep analysis of the model, and for that it's always advisable that to separate the model into small and isolated areas where it's easier to analyze the flow and check what's happening at each of these isolated areas. Um, so here in this step, possible misplaced data can be identified and corrected at this stage.
Okay, thank you, Cora. Another question we had come in, how do we select the correct software that'll be used in a particular project?
Okay. Here, before proceeding with a specific software, we must pay attention to the project's requirements. So I'll give you some examples. If the project requires a 3D animation, we should list at the first moment the software that has this functionality, because not all the applications have this feature. And we need to see what level of detail is required of this 3D animation. Uh, Another good example is the programming language, as explained before. Which language is required for modeling the system? Should we use a syntax language, or should we use a Pascal or C sharp? We'll model some kind of automated guided vehicles into our model, or we will include and model some robots into our layout. So through these questions, we can select the software that best meets the project's requirements.
And I'll remark, PMC periodically runs a webinar, a separate one devoted to that very topic. So stay tuned.
Yep, thank you, Ed. Thank you, Cora. At this time, I don't see any further questions coming in. So with that, we'll close the Q&A session. So thank you guys for answering those questions. For additional topics, like you said, that might be coming up, be sure to visit our website and click on www.pmcorp.com and click on the resources tab to look at and register for other PMC webinars. Also, this presentation was being recorded, so we recommend you visit our YouTube channel, search PMC videos, that's videos with an S, for other topics that interest you and your team, like this one. It'll be up on our channel either later today or early tomorrow, depending on when we can get it edited and put it up for you guys. If you want to review the slides, share it amongst your colleagues, we recommend you do so. So with that, that will conclude today's webinar. I'd like to thank everyone for your participation and attendance. If you think of any additional questions later on, or you'd like to discuss how PMC can help you design and implement your own process improvement strategies, please contact us at one of the addresses now on your screen. We look forward to working with you or perhaps joining you at another one of our PMC productivity improvement web seminars. Thank you and have a great day.